Okay, here's some notes on logarithms that I kind of wrote up. The definition of a logarithmic function. And this is a formal definition. These are important. We'll go back and try to get more of an intuitive idea of what we're talking about. But the definition of the logarithmic function for x greater than 0 and b is greater than 0 but not equal to 1, y equals, and we call this log to the base b of x. So y equals log to the base b of x, if and only if that means it goes in both directions. B to the y equals x. So this is what we call a logarithmic equation. This is what we call an exponential equation. And these are equivalent. So sometimes it's a lot easier to write our logarithmic equations as exponential equations because we've already studied those. So again, we say the function f of x equals the log to the base b of x is the logarithmic function with base b. And this would be the exponential function with base b. Now, if you think about this, what we're saying here, if this is y equals log to the base b of x, and this is b to the y equals x, well, since y is this whole thing, then this whole thing is an exponent. So in other words, we can say the logarithm is an exponent. And I kind of wrote it over here, y equals log to the base b of x, and that's equivalent to saying b to the y equals x. Well, instead of writing y, I can write this. You can see that this is an exponent. And this really is the exponent that when I raise b to it, I get x. So it's kind of like the answers in the wording. In other words, this is the exponent. Then when I raise b to it, I get x. And you can see that b to this y equals x, or b to this log to the base b of x equals x. Now this is, again, this is what we call the logarithmic form. It's a logarithmic equation, or a logarithmic function. This is the exponent. That's the base. In other words, b to the y equals x. And this is the exponential form, and again, there's your base b, and there's your exponent y. So since y equals a logarithm to the base b of x, I'll say it again, this is an exponent. So if you have an intuitive understanding of these, sometimes you can kind of evaluate logarithms. And here's an example, or note. So if we look at this, this is my log to the base 2 of 8. This is the exponent that when you raise 2 to it, when I raise 2 to this exponent, you get 8. So 2 raised to what power is 8? Well, I know the 2 squared is 4, and 2 to the third is 8, so I could write 3. So 2 to the 3 is 8, so log to the base 2 of 8 equals 3, because that's the exponent. Now you may have to think about this, you may have to stop and pause it and go back. There's nothing wrong with that. Sometimes it takes a while to get these concepts in your mind, but if you think about this and you understand intuitively what's happening with these exponents, then it'll make it a lot easier. Okay, so let's try some examples of how we can use some of the data I just talked about. So first of all, we're going to change logarithms to exponential form, and we're going to kind of use this idea up here that if y equals log to the base b of x, then b to the y equals x. And again, this is my base, this is my exponent, and that's my answer. Okay? Okay, so first we're going to write these. Changing logarithms to exponential form. We're changing from logarithmic to exponential form, excuse me. So this is in logarithmic form. So again, what's my base? My base is 4. This is my exponent, 3. And there's my answer, so that equals x. And that's all we have to do. We can evaluate that if we can. In this case, we could. 4 times 4 is 16, times 4 is 64. But this is all right. We're going to change it from logarithmic to exponential form. Okay? Example. So the second example. I could call this example 1, 2, and 3 if you want. So here's example 2. And what's my base? B. What's my exponent? 5. And there's my answer right there, 125. Base, exponent, answer. Okay? What's my base? 4. What's my exponent? Y. I kind of reverse these around. Log to the base 4 of 16 equals y. So this is my base. This is my exponent. And there's my answer, 16. Okay? So let's take a look at how we did that. Base, exponent, answer. Base, exponent, answer. Base, exponent, answer. Base, exponent, answer. And base, exponent, answer. Okay? Now going the other direction, changing from exponential to logarithmic form. If we're going to have logarithmic, we're going to have some logarithm. And what's my base? In this case, my base is 14. And what's my answer? My answer is x. And what's my exponent? 3. Okay, this is my base. There's my exponent, there's my answer. So when we look at this, it's always base, exponent, answer. So 14 to the third equals x. You can always check it real fast. Okay, I did this example. We could call this example 1, 2, and 3 again. I didn't label these, but. So here's example 2. So we're going to have log. We want to change it to a logarithmic form, so write log. Now what's my base? Well, it looks like my base is b. Looks like my answer is 27. And this is my exponent 3. I'll have the same exponent. Again, base, exponent, answer. Base, exponent, answer. All right? And the last, example 3 here. Now my base in this case is e. We'll talk about that a little bit more later. My exponent is y. That's what the logarithm is equal to. And my answer is 11. So base, exponent, answer, e to the y equals 11. All right? Okay, and then we're going to be evaluating logs. That means find the value of. These are kind of like our first examples. This is example 1. So this is the exponent. When I raise 3 to it, I get 81. So 3 raised to what power is 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81, so we'd say 4. So we can say that's equal to 4. If you have problems with that, then let's just call this y, and what we're trying to find out is what the y is. And then we can change it to an exponential equation. What's my base? My base is 3. What's my exponent y? What's my answer? 81. And then we have an exponential equation, and we know how to solve that. We try to get both sides of the same base. All right? So what base would that be? Well, let's say that's 3. So we could say 81 is the same thing as 3 to the 4th power. And that equals 3 to the y. And we know from our exponential equations, if my bases are the same, my exponents are the same. So I could say that 4 equals y. So that would equal 4. So intuitively we say 3 raised to what power is 81, 4, and then, or we can solve it analytically by changing it to an exponential equation. Okay, let's try some other ones. Again, these are evaluating logarithms, and this example is log to the base 25 of 5. This might be example 2. So 25 raised to what power is 5? So that might be a little bit, confusing to me. So I'll just say, let that equal y. And then I'll change it to an exponential equation. What's my base? 25. What's my exponent y? What's my answer? 5. And then we have a nice exponential equation, and we try to get everything to be the same base. So we'll say this is the same thing as, I can do it over here, let me write it over here. 5 to the 1 equals, and 25 is 5 squared to the y. And that's the same thing as saying 5 to the 1 equals 5 to the 2y. And now my bases are the same, so therefore the exponents are the same. So I could say that 1 equals 2y. And if I divide both sides by 2, y equals 1/2. So that's 1/2. Okay, let's try another example. Example 3. Log to the base 5 of the square root of 5. What's that? That looks kind of confusing too, so I'll call that y. And again, I'll change it to an exponential equation. My base is 5. My exponent is y, and my answer is the square root of 5. But the square root of 5 is the same thing as 5 to the what power? 1/2. So that's the same thing as 5 to the 1/2, which equals 5 to the y. So since my bases are the same, the exponents are the same, so that's going to imply that 1/2 equals y. Now let's try one more. I hope that makes sense. The bases are the same, the exponents are the same. Remember, the square root of 5 is the same thing as 5 to the 1/2. And this is example 4. Log to the 1/2 of 4 equals y. Well, basically this is log to the 1/2 of 4. And I'm not too sure what that is, so I'm going to call it equal to y, and then I'll change it to an exponential equation. So what's my base? 1/2. What's my exponent? Y. And what's my answer? 4. So I'll try to get these both to the same base of 2. This looks like 2, so this is the same thing as 2 squared. Now 1/2 is the same thing as 2 to the negative 1, so I could write that as 2 to the negative 1. And that would be to the y power. And then I'll just multiply this out, so I'll get 2 squared equals 2 to the negative y. And now, again, my bases are the same, so the exponents are the same. So I get 2 equals negative y. And that means, or that implies, that positive y equals negative 2. So this would be negative 2. So 1/2 to the negative 2 equals 4. So if you take 1/2 to the negative 2, that's going to be 2 to the positive 2, and 2 to the positive 2 is 4. So that makes sense. All right? So hope those examples help. And you may have to look over them several times before they really lock in.